Hello. Today we'll be doing conic sections. Yay.
Okay, thank you, mystery guest. So yeah, we're doing some conic sections. You should have already watched the video that explains the geometric interpretation of conic sections. And depending on how we slice this double napped cone, we can get a hyperbola, we can get a parabola, ellipse, a circle. So that was in our last video. In this video, we're going to start off by looking at the general form of a conic equation. And what you typically have here is you see we've got an x squared term. We have a y squared term. Oh, wait, let me do it this way. We have an x squared term. We have a y squared term. We have an x to the first, a y to the first. We have a constant with no x or y. And then we have this combination term, the xy term. A lot of times this term, the xy term, is going to be not there for what we're doing. So I'm going to back all that up. All right, so this is our general form. Most of the time, A will be bigger than 0, which means A will be positive. And B will be equal to 0, meaning no xy term. Okay, that's most of the ones that we'll be looking at. So here's how we can tell what you have. Now, we're going to skip over circle for a second. It's one of these three things, an ellipse, a hyperbola, or parabola, based on the discriminant. So we're talking about B, C, and A, the squared terms and the xy combo term. Remember our discriminant, it's related back to our discriminant of a line. It's the part under the square root, b squared minus 4ac. So this is our discriminant. You might want to write it somewhere a little bigger than that. And that's going to tell us if we have an ellipse, a hyperbola, or a parabola. So for an ellipse, it's going to be b squared minus 4ac will be less than 0. In words, that means the discriminant is negative. For a hyperbola, it's going to be b squared minus 4ac is bigger than 0. And for the parabola, it's going to be b squared minus 4ac equals 0. That's how we're going to be able to tell which one we have. So that'll be a question. You'll be given this equation in general form, and we'll ask you which one it is. Now, a circle is a special case of an ellipse. So what that means is if it's an ellipse, step 1, b squared minus 4ac needs to be less than 0. And then for it to be a circle, the a and the c must actually be equal. All right, so let's look a little deeper into what these actually mean. There's kind of like a corollary for each thing. So we're saying that b is almost always 0. So I'm going to take us through a typical case. Typically, b is 0 and a is a positive number. So what determines if this whole thing, I'm going to do this in a different color, what would determine if this whole thing is less than 0 or not means it would be negative. I would need this to also be positive. So if c is positive, so both A and C being positive, right? Remember, that's A and that's C. That's typically what we're going to see in a more specific case. The discriminant will turn out to be negative if C is positive. Again, that's provided B is 0 and A is positive. We're always looking at A as positive because we don't want to start out our general form with a negative coefficient. So it's almost always positive. And this term is almost never there. All right? So we want no negatives and to start, and basically no xy term. So that means that it's an ellipse when the c is positive, essentially. Okay? It's a hyperbola when, same thing, typically b is 0 and a is positive. So then what does the c have to be? For this whole thing to turn out to be positive, I'm going to have a negative 4 times a positive. That part right there is going to be negative. So I need this to turn out to be a positive, so that means that this c better be negative. So typically c is negative if a is positive and c is negative. All right, so what these look like typically are things like this. A is positive, so maybe we have like 4x squared. The xy term is missing, and then plus, say, like a 2y squared, and then some other stuff equaling 0. But this is what we're focused on. Typically, that's what an ellipse will look like when we have addition there. And a lot of times, we'll have some fraction ones like x squared over 4 plus y squared over 2. But it's the idea that both of these are positive. That's what makes an ellipse. A hyperbola would be when c is negative. So maybe if I had a 4x squared minus a 2y squared, some other stuff equals 0. When this y squared term is negative and the x squared term is positive, that's when we have a hyperbola. And again, we might see them like as fractions. Still the same thing. Right? So these are typically what we see. What we start to say is the x squared and the y squared have different signs. One is positive and one is negative. One is positive, one is negative. Up here we say when they're both positive, typically. Positive, 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 positive. All right? And then lastly, the parabola. If my discriminant is going to be 0, that means typically b is 0. The ones that we're going to see in this class. A is positive. So what does c have to be for this whole thing to be 0? C has to be 0. Right? So that'll make a parabola if c is 0. Here's one case where the only thing is if a, there's another typically. If a, I wanted to say this. So c would have to be 0. Typically, a is positive unless we will see some where a is 0. And then in which case c would either be, typically positive. So then, in this case, a would be 0. So for our parabolas, typically one or the other is 0, not both. But if one or the other is 0, that's how we'd have a parabola. So that's how we can tell. And we'll come back around to this with some practice problems in class, and it'll make a little more sense when we do some of that. All right, today we're going to focus on the special case of the ellipse, which is the circle. We're going to focus on a circle. Now, a circle is a special case of an ellipse. An ellipse has two centers. Those are they're each called the focus, or together, plural, they're called foci. And if I keep bringing those together, closer together, the ellipse looks more like a circle until both foci make one center point, and that's a circle. Basically has one center, not two. So when I say focus on a circle, there's a joke there too. My jokes are funny. All right. Back to geometry, the graphing form of a circle is a little different than what we talked about here today. We would have like x minus h squared plus y minus k squared equals radius squared. If you recall back to geometry, that was our form of a circle. And that would have been where hk is the center of the circle. And r is the radius of the circle. Like, to define a circle, I kind of think of it like this. Like, we need a location and we need a size. That's how we work with circles to make them unique. Center kind of tells me where it's located. The radius, the length of the radius, will tell me the size of the circle. So let's look at an example from geometry, remind ourselves. If it's in the graphing form. I think translations. This means that our, by the way, our parent circle, the main circle, is always centered at 0, 0. That's like before we translate it around. It could have any radius, okay? But it's centered at 0, 0. So when I think of translations, this was shifted. This means shifted right 4. And since this is with the y, it would mean shifted down 2. So if I take my parent centered at 0, 0 and I go right 4 and down 2, I have my new center at 4, negative 2. So that jives with what I'm seeing here. If you recall back to our formula, or I should say our form, HK is the center. So H is 4 and K is negative 2. Because it's always the opposite of what you see. Because remember in the formula, it's X minus and Y minus. So it's the opposite of the H and the K. So this should be 4, negative 2 is my center. Again, this is kind of a refreshing from geometry, refreshing what we learned in geometry. And then 4 is equal to r squared because the formula says it's equal to r squared. So if r squared is 4, I can square root both sides and get r is the square root of 4, so r is 2. So I can have the center and the radius given this graphing form, okay? So there's two main types of questions that we deal with circles. One is find the center and radius given an equation. We just sort of did one of those. And the other is write the equation given some information. So let's do some of these examples. Find the center and radius of each circle. So I think this was shifted, since it's grouped with the x, it's going to be left or right. This would be shift right 3. And since it's grouped with the y, it would be shift down 5. It's always the opposite when they're grouped with their proper variable. I can go on a whole thing about that, but we talked about shifting in the beginning of the year. So that means the center of this circle is going to be 3, negative 5. Most people just remember it's the opposite of what you see in here. The x-coordinate is grouped with the x, and the y-coordinate, negative 5, is grouped with the y, and it's the opposite of what you see inside your equation. I like to think about the shifting. And then the radius is going to be, remember this right here is r squared. So the radius is going to be the square root of that. So the radius is 6. There's our radius. There's our center. Let's try the next one. This one is shifted left 7, and it's not shifted in the y direction at all. So that means our center would be negative 7, 0, which jives with what we're saying. We can think of y squared as y minus 0 squared. If you like, you take the opposite, you take the opposite. Well, 0 doesn't have an opposite. This is r squared, remember? So the radius is the square root of that. So our center is that, and our radius is square root of 17. There's no simplification that I can do there. All right, so let's come back to that other question. So is this a circle, an ellipse, a hyperbola, or what was the other one, a parabola? Has to do with A, B, and C. So remember, A is 1 in this case. B is 0 because there's no XY term. It's missing. C is 1, and so now I can do my discriminant. So B squared minus 4AC is 0 squared minus 4 times A times C. That number is negative 4, and negative 4 is less than 0. So whenever the discriminant is negative, we have an ellipse. And the ellipse might even be a circle, the special case of an ellipse where it's a circle. And that's going to be when A is equal to C. which it is because A is 1 and C is 1. When these are equal, I have a circle. So because A equals C, which is equal to 1, we have a circle here. All right, so that's how you can determine what kind of conic section we have. Let's go a step further now. Since we have a circle, I'm going to rewrite it again. X squared plus y squared plus 8x minus 12y minus 48 equals 0. We want to look at how can we put this into graphing form. Okay? So in other words, what's this? I'm giving you the equation here. It's like our first type of problem. Given the equation, find the center and radius, right? So we can't find the center and radius from this form. We have to put it into graphing form. So let's take a look at how we do that. So the first thing is we group the x's with the x's and the y's with the y's. And then we bring the constants over. So I'm going to add 48 to both sides here. Right? And then I grouped the x with the x and the y with the y. I just rewrote them. All right? So now what we're going to have to do is complete the square. I want to turn it into this form where it's like a perfect square, x minus something squared, and then same thing with the y's. So I'm going to kind of group these and say x squared plus 8x plus, I can add some number to make it a perfect square trinomial. So if we remember how to do that, you take the b term, 8 on the side, divide by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. So I just added 16 to make a perfect square here with my x's. So now I can factor it. When it's a perfect square, I can factor it as something squared, right? So that something is going to be x plus 4 because it ends up being this number inside here. I'm blowing through this quickly because this is review supposedly. So that's called completing the square. I added 16 to make this a perfect square trinomial, and now I factored it into x plus 4 squared. Now it's in graphing form. The thing is, if I add 16 on the left, I got to add 16 on the right. So actually, I'm going to write that here. Equals 48 plus 16. Keep the equation balanced, okay? Now I'm going to do the same thing. I'm going to complete the square with the y's. So I've got plus y squared minus 12y plus something. I can make it a perfect square. The way you complete the square is take that b term, negative 12 on the side. It's not really the b in terms of this whole thing, the x squared, y squared, x, but it's like just looking at the y's, it's like a, b, and c, right? So negative 12 divided by 2 squared, that's how we complete the square. I get 36. So if I add 36 on the left side, I got to add 36 on the right side to keep everything balanced. Okay, why did I do that? Because now this is a perfect square trinomial that I can factor. It's going to be y minus 6 squared. Now on the right side, I have 48 plus 16 plus 36. That equals 100. So now it's in my graphing form. I didn't answer the question. We still want to know what's the radius and what's the center. So the center is negative 4, 6. The radius is the square root of 100, which is 10. So there's our center and our radius. Let's try another one. So can we find the center and radius given the equation? Well, it's got to be in that graphing form. So again, I'm going to start by grouping my x's together. So I'm going to move this next to the x. And then I get plus 3y squared plus 24, whoops, that's 24y. Equals negative 18. I should back up a second and review how we know this is a circle in the first place. If I do the discriminant, to know it's a circle, b squared minus 4ac. So the discriminant is a is 3, b is 3. Sorry. B is 0 because there's no xy term, and c is 3. So if I do this discriminant, I get 0 squared minus 4 times 3 times 3. I'm getting, negative 36 for my discriminant. So whenever my discriminant's negative, this means we have an ellipse. because the discriminant is negative. And when it's an ellipse, it might be the special kind of ellipse, which is a circle. When A equals C, which it does in this case, they're both equal to 3, then we have a special ellipse called a circle. That's when the two centers are together, the two foci line up and become the center of the circle. All right, so then how do we change this into graphing form to find the center and the radius? We group the x's, we group the y's, and we bring the constant over. So now I want to complete the square again. Well, we can't have a number in front of x squared, so the first thing is I want to factor out my 3 and then complete the square inside the parentheses. I want to do the same thing with the y's. All right, and now I can complete the square inside. I take that negative 2, I divide by 2, and I square it, so I get negative 1 squared is just 1. So that's going to give me the plus 1. Now, I have to balance the right side of the equation. I added 1 over here, right? I added a 1 right here. Actually, I'll highlight it. That looks weird with that blank. Let me take that blank out of there. I added 1. So what do I have to add to the other side? I have to add 3. Well, wait a second. If I added 1 on the left, why did I add 3 on the right? Oh, because I didn't really add 1. I added 1 in the parentheses to get what I really added was this 3, remember, has to distribute to everything I put in the parentheses. So since I put the 1 in the parentheses, the 3 would distribute to it, and what I really added was 3. So that's why I got to add a 3 over here to keep it balanced. Let's do the same thing with our y's. If I take that 8, divide it by 2, and square it, that's how I complete the square. I get a 16. So if I added 16, if I added a 16 over here, I'm going to add a 16, but times the 3 that would get distributed to it. And that's what I'm adding over here. All right, we're lined up to factor. So this becomes 3 times x minus 1 squared. That's how I factor this perfect square trinomial. Plus 3 times y plus 4 squared. Right? I'm looking for what number, when you add it to itself, gives you the middle. When you multiply it times itself, gives you the end. That's how we factor a perfect square. Equals negative 18 plus 3 plus 16 times 3. That whole part will come out to be 33. We're not quite yet at our graphing form of a circle because in graphing form there were no numbers here in front. So we've got to divide both sides of the equation by 3. So these all cancel over there because I divide each part by 3, right? So these cancel. And then over here I get 11. So x minus 1 squared plus y plus 4 squared equals 11. So then the center is 1, negative 4, and the radius is the square root of 11. Okay, now let's look at the other type of question. If they give you some information, can you write the equation of a circle? So a circle centered at negative 5, 2 with a radius of 8. So I can use my x minus h squared plus y minus k squared equals 8 squared. I can write equals r squared. That's my general form in the graphing form. So if I know the center, I can say x minus negative 5 squared plus y minus 2 squared equals 8 squared. So if I simplify that, I get x plus 5 squared plus y minus 2 squared equals 64. That would be my equation in graphing form. They didn't ask for general form. If they wanted general form, I would have to do this. Don't write this part down. You could just watch this part. If I wanted general form, I'd have to square the x plus 5. So that gives me x squared plus 10x plus 25. Then I'd have to square the y minus 2 part. I get y squared minus 4y plus 4, minus the 64 equals 0. And then I can start rearranging these terms. I could add the 25, the 4, and the negative 64 to get 29. 29 minus 64 equals negative 35. So I did those. I took care of those. Then I would have x squared plus y squared plus 10x minus 4y. That would be the same thing in general form. So it would depend if they asked for that. You would have to multiply it out. Right now we'll be good with just our graphing form. Okay? A circle centered at 0 means, again, x minus h squared plus y minus k squared is our graphing form. Equals r squared. Remember that from geometry. So x minus 0 squared plus y plus, sorry, I'm already kind of simplifying, minus negative 6 squared equals root 40 squared. Simplifying, I get x minus 0 is just x plus y plus 6 squared equals 40. Again, if I wanted general form, I could multiply out the y plus 6 squared and rearrange some terms. So that's how we get the equation given some information. We've got 3 more to do. All right. A circle centered at negative 4, negative 7, passing through the point negative 1, 8. So that means that we've got to find the radius. We're given the center, right? So I've got x minus negative 4 squared plus y minus negative 7 squared equals r squared. So x plus 4 squared plus y plus 7 squared equals, but we don't know what the radius is. So now let me do a quick sketch of this graph. If I go left 4 and down 7, maybe I'm here. That's my center. And then there's a point, negative 1, but up 8, that's on that circle. So there's my center, there's my circle. The radius will be the distance between these 2 points. So I can do my distance formula, which is the square root of x minus x squared plus y minus y squared. So I get 3 squared plus, I'll just do this out. 3 squared is 9 plus 15 squared is 225. I'll get the square root of 234. That's my radius. So maybe I'll call it r instead of d. I was doing distance formula, but we were finding the r. So there's my radius of the circle. So now if I plug my radius back into the formula, I've got the square root of 234 squared. So now my final version, I go a little faster because I don't want my video to be too long, and you can always rewind or pause. All right, so now let's try this one. This time we've got a circle. I go left 2 and up 3, maybe that's right there. And then right 4, and then down 9 is maybe there. I've got this circle that passes through these. So how do I find the center? Well, the center is going to be the midpoint of that diameter. So if I do the midpoint of these 2 points, I'll find the center. You did all of this kind of thing in geometry. Midpoint is just average the x's and average the y's. So I get 1 comma negative 3. That's going to be the center. And then how do I get the radius? I could do the distance formula from the center to one of these points, or I could have just done the length of this, which is my diameter, do this distance formula, and then cut it in half. I'm going to do the radius goes from the center. So the radius is the distance formula from the center to one of these points. I'll use this point. So x minus x, 1 minus negative 2 squared, plus y minus y, negative 3 minus 3 squared. So my radius is going to be, that's 1 plus 2, so squared is 9. And then negative 6 squared is 36. So my radius, I'm getting, I want to make sure I'm on the right track here. My radius is the square root of 36 plus 9 is 45. So then if I write my equation, the center is x minus 1 squared plus y plus 3 squared equals radius squared. So if I simplify that, I've got x minus 1 squared plus y plus 3 squared equals 45. For a challenge problem, I'm going to ask you to see if you can come up with the equation given for the circle given this information. That's your challenge.